Oh, there it is. Jerry Martin is first. Hello, Francis. Yum, yum. How are my critters today? Happy, happy critters. Oh, really? That's good. Hello, Matt. How are you doing today? Happy, happy critters. Hungry, happy critters. Tasty, yummy critters. Be happy critters. Yummy, happy critters. Not what I wanted to do. So what are you up to lately, Matt? Ooh, mini fridge for 35 bucks. I might have to go grab that. Ooh. Wow, nice aluminum box for 70 bucks. More than I got though. How big is it? Damn it. Jesus. Sauce organization is waiting for some critters to show up. How you doing that, Bulgarian? Jesus. I keep mistyping. There's a little microwave I'd like to get. But dang it, it's up in Taos, which is pretty far away. Hmm. Where the heck is White Rock? Los Alamos. That's not that bad. But he wants too much for him. $60 is what they cost in the store, pretty much. That water distiller is working great. And the locals were right. The coffee does taste better with distilled water. Yum, 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 yum. So I got these, I've been collecting these sauce packets. They usually are pretty generous, giving me extras when I ask for them. I especially love having honey packets, of course, because I love honey. I love the little salsa packets that I get from Sonic, because whenever I make eggs at home or something like that, these are great for sticking on your eggs. Of course, everybody loves the taco mild sauce. And then, of course, one of my favorites, the Arby's horseradish sauce. Oh, I love this stuff. So, most of the little tubs are this size. So I can pretty much scale everything for this. The honey is a little shorter, but it's the same size, length, and width. So I think I can use the same size container to release the honey. You just have to be careful you don't accidentally pull two out, because it's almost exactly twice as tall, but not quite. It's almost exactly twice as tall. The question is, can I get away with designing the one for the packets to all use the same size? Because like the Taco Bell's the smallest, then the salsa, then the horseradish. So can I design for the horseradish and put all of them in it? I don't know. That's a good question. But I'm thinking I could probably get away with just chucking a bunch of these down inside there. And as long as it's big enough that they don't clog. So I'm thinking just design for the horseradish. This way I only need 2 designs. One for tubs and one for packets. Doing all right. How you doing, Rick? So I guess let's design for the biggest tub first. Let me switch this so you guys can see what I am doing. Nice. 1,000 pounds. That's a hefty price, but it is a nice machine. And there we go. You guys can see what I see. Okay. Call it. They are 55 millimeters. So let's design for 60. And they are 43. So let's design 60 by 50. 60 by 50. And how tall? No matter what, you should get good results out of a machine like that. So it is 24 millimeters tall. Excuse me. And then now, how big is the sauce packets? Let's use the biggest one. Did you receive your big battery pack? Big battery pack? Oh, you mean the battery box that I'm reviewing, or battery pack for what? The big 1.5 kilowatt USB battery pack, I got that. But as far as the other battery, oh, the one that was never shipped? No, they lost it, so I got a refund. I was like, yeah, it's been 30 days. Sorry, buddy. Yeah, 30 days. I gave up. Let's see if this is accurate. 10 to 10. Yes, it is. Okay. So this one is 103 by 38. So let's call it 105 by 40. And is about 12 tall. So there's our sauce packet. There is our tub of sauce. Now, of course, I want to design this to be vase mode printable to minimize both time, failure, and waste. It was a pity because I was looking forward to that battery because it was 500 watt hours and it was orange, and I like that. I like the idea of it being 500 watt hours is nice, but I like that it was orange. Okay. So that means we're going to have two distinct shapes because the sauce packet is substantially bigger than a tub. How do I want to do this? Oof, I wish I could have that. Well, dirt cheap is relative. You know, relative to what batteries cost a few years ago, they're dirt cheap. Relative to my budget, they're unobtainium. I couldn't afford one 200 amp hour battery. But four is nice because that means you can run a 200 amp hour 48 volt battery pack. And you probably will want to run 48 volts, even though the inverter will cost you more, because it'll be far, far more copper efficient. You won't have to use, you know, naught gauge wire to run any kind of amps to that thing. Hello, Photominima. So that would be 48. 10 kilowatt battery. Wow. You'll have right around 10 kilowatt hours of power. Boy, now that I think about it, that's almost enough to run this house. Matter of fact, I'd have to go like 250 amp hour, 300 amp hour, but then four of them would run this entire house. I use about 12 kilowatt hours a day. Jesus. Actually, that's more than enough if you don't run the HVAC. Damn, that's awesome. Yeah, Power Queen got a pretty good review too. There's a guy I watch on YouTube, and he seemed to think that the Power Queens were halfway decent. You know, build quality and whatnot. Except watch, most of them do not have low temperature protection. Meaning there's nothing to stop them from charging when they're frozen, which will damage the batteries. So make sure you use an insulated box or you have them indoors or something like that. Don't put them outdoors. Okay, so the best thing is probably just to simply oversize them a little bit. But if you oversize too much, they flop around. And you don't want that either. Yes, you want, ideally, if you can afford the money, what you want is, well, you should worry about it with lithium iron phosphate, because the advantage of lithium iron phosphate is if you worry about it, that could be the difference between a really long battery life and a lifetime battery life. In fact, you're more likely to have the BMS fail than the batteries fail. But if you can double the size of your battery for what you need, so for example, I need 12 kilowatt hours for my daily consumption. So ideally, I would want a 24 kilowatt hour battery. Because if I used a 24 kilowatt hour battery, I would only be cycling the battery once every 2 days. Even better would be a 48 kilowatt hour battery, and then I would be cycling the battery once every 4 or 5 days. Because a cycle is a full charge and discharge. So if you only discharge 20% and then recharge back to full again, that counts as a fifth of a cycle. Which is far less damaging to the battery overall. It'll also make it a whole lot easier for you to run high amp loads, because the more batteries you have, the less stress there is on each individual battery to handle that load. You should be able to handle a 9 kilowatt load on that battery, which will run absolutely anything in your house. I mean, even an electric water heater is only 4.5 kilowatts. I got these. I collect these sauce packets whenever we go to, you know, any kind of fast food place. I ask for a little extra, and they usually give it to you. And you know, especially Taco Bell, you know, you can put in the app 20, and they'll give you 20. So I got a drawer full of these sauces, and I want to make little dispenser things for them. We use EM. What's that? Right now, they're all just filled in a drawer, and it's a bit limiting. Oh, use them. Okay. So actually, it would be easier for me just to take the sauce packet and increase the dimensions. Yeah. So Control D. Now, I want to add 0.2 millimeters per side, so that's 0.4. And I want to add 1 millimeter for the wall. But I'd actually rather have the wall be at least 2 millimeters thick. Yeah. So that's 4 millimeters. Oh, nice. I wish I could sell printers easier here. It's very hard. I've tried to sell a couple, even of the nicer printers, and it's just, in 3 years, I've sold one machine. I don't live in a very good area for selling 3D printers. Back in Philadelphia, I could probably sell every one of them. But here, it's very difficult to sell printers. Even during the boom when people were um when we were making the face shields and it was popular, even then I couldn't sell any printers. The prices they wanted to pay were just not worth selling them for. Of course, I can't ship. It's too expensive to ship. Which one? Oh, the X1 Carbon. I've heard some sketchy stuff about the reviews, though. Like them wanting to vet videos before you post them. I'm like, no. That's not acceptable. Let's see here. So if I want 2 millimeters, that's not very thick, though. Let's go to 3 millimeter wall. So 3.4 millimeters, 63.4, and 53.4. That gives me enough for tolerance and for wall thickness. Let's get rid of let's change the color. Let's keep the radius. I like the soft radius. Yeah, no thanks. All editorial control is mine, or I don't want the printer. See you later. Wow. Where do you live? Let's see, let's make it 200 millimeter tall. Yeah. That's why, very dense population wise. So you have a large market, which makes sense. Okay. So that takes care of that. So it has a hardened nozzle. Yeah, the nylon always needs to be dried out. Very rarely do you get nylon that doesn't need to be dried out. Although I did get a roll of nylon CF from Esun that required no drying out. He lives in the UK, United Kingdom. I thought he did. So let's see here. How do I want to do this? So this is 63.4. I'm going to shrink this just so I can get access to it. Hey, leggings under fleece pants are very effective at keeping you both dry and warm. Let's see, let's make the bottom 5 millimeters thick. 4 millimeters is probably enough. And I was able to print the nylon CF from Esun open air, on my Ender 3, no problem. It's good material. Well, hardened nozzle, of course. Or that carbon fiber will tear it up pretty fast. Okay, now I need to increase the size of this by 0.4 or by 50.4. Ooh, actually, I need to make that 0.8. No, 0.2 tolerance. Should be okay. Oh, you know right away. Snap, crackle, pop, baby. Okay. Um, that should give me my hollowed out cavity. Now I duplicate this and stretch it all the way out the top. Let's get rid of this. Let's bring this back down to... Come on. I hate when it hides the goddamn... How could it not be smart enough to know I need to see the number? We just gotta hide it. Okay. Oh, I didn't want to delete that. Let's change the color. This way it's different. Let's bring it out this way. Three. And bring you down to 3. And bring you back out to 63.4. Okay. So now we turn this back into a solid, this into a hollow. We duplicate this. We bring it out to here. Like that. All right, and the next thing I need to do is to shorten this. What was the height? 12? Let's call it 14. And then we just invert it. Take this and this, merge it. There we go. Make this Control D. Okay. Turn that into a transparent as well. That should actually do it. I think I want to make this a hair bigger. Yeah, that worked good. Hey. Okay. So now what I want to do is I want to put an angle on this. I think that means I want to put the plane here, put this here, rotate this 90, lengthen, rotate 180. And then increase the size. Go up a hair. Let's bring the angle down. I like that. That gives us a nice angle. Okay. Now let's reinforce, let's put the initial cut in the back. Let's bring it up. No, we got to keep it at 0. Mm-hmm. 0.01. Center it. Okay, that gives us vase mode. Now I do need to chop off a little bit on the top here. Because I need this top to be pretty firm. There we go. Actually, that's not tall enough. Why is this so thin here? It's like it's uneven. Why is that so uneven? Let's get rid of all that. Yeah, this wall's thinner. It shouldn't be. The little cut is so I can print it in vase mode. So this is going to have an inside wall and an outside wall. See, if I made this just pure vase mode, it'd be very floppy. It wouldn't be very strong, especially with a 0.4 millimeter nozzle, which I'm going to use. So to give a little integrity to it, I'm going to print it with 2 walls, an inside wall and an outside wall. But in doing that, it's now no longer vase mode compatible. So by putting, because now you have an inside stop and an outside stop. You can't do that with vase mode. But if I put a cut in it, The inside surface is now connected to the outside surface. So now I can draw the inside, move through the cut and draw the outside, move through the cut, draw the inside, move through the cut and draw the outside. So now I can still print this in vase mode while having two walls. And I can also, like I did with this here. This here is a vase mode printed box. Yet it actually has thickness. And then I put these ribs in here. So one of these, this one right here, goes all the way through. So it cuts all the way through the model. While these here cut almost all the way through the model, but not quite. They touch the outside, but don't cut through it. This way I have ribs for reinforcement. So this is a nice, strong, sturdy box, while still being vase mode compatible. Vase mode means no retractions, so it's very smooth. It's also less prone to errors. Even if you have shady filament and a shady printer, it's okay because it's vase mode. You're continuous extrusion all the way through. So it dramatically increases the probability of success, even for a beginner. It reduces the amount of material you need, yet still gives you the structural integrity you need to build, like this. Like this here, I reduced the print time of this box from, the way the guy designed this, he was printing them at 13 hours each. I reduced the print time to 3 and use half the filament. You can make surprisingly complex shapes, all with vase mode. So this whole entire fin can, including the interior motor mount, including the eye hook holders, including the launch lugs, everything, this is all one single vase mode print. Takes a little work in the designer to do that in the software, but once you know the tricks, it's not that hard. It's just meticulous. So that is what I'm trying to avoid right there. See how that slit touches the bottom there? It doesn't really matter, but it annoys me. So if we go back. So if we go 0.1, that should get rid of that. But first I need to undo this because something's wrong. Okay, there is my angle cut. All right, so something is wrong with these shapes. That's 50.4. That's 53.4. Are they not centered? They might not be centered. And center. Okay. Let's try that. Can I just join them all together? Sometimes you have to do it in a certain order. No, that worked. There we go. That looks good. And we don't have that cut on the bottom there. That's good. This also allows you, this vase mode method also allows you to do things you normally can't do with vase mode. For example, have an opening here. Normally, you can't have an opening in vase mode because you'd go around, and where would you go after that? Well, you just keep going around the other way. Now that you have vase mode, you can do that. So the reality is I actually need to raise this here this high. I can't have that be at that level. I have to get rid of the bottom part of that slit. I believe I used this as the cut tool. Yes. So I can use that to cut my slit. Okay, so let's so I need to make this temporarily a solid. This I need to make a cut tool. Do this. And join. And now join. Oop, I didn't quite cut it all the way. That's okay, it's in midair. So now you can see the, oh, I forgot to turn it back into a hole. There we go. So because this can actually wrap all the way around, I don't need a slit below this level, but I do need a slit above that level because this is now a complete circle. And I want this to be double wall. Okay, that looks good. And another little trick. What can I do here? I don't need a trick here because I can put a hole right there. And I can also put a hole back here. I think. No, it's all right. Okay. That looks good. Now I want to put a rib in place to reinforce the let's see, this is 63.4. I'm using a 0.4 millimeter nozzle, which means I need a 0.8 millimeter separation, which means I need a 1.6 millimeter deviation. Okay. So 63.4 minus 1.6 would be 61.8. Okay. I need to, the ribs are going to be full height, but we are going to lift them up 0.1. We're going to make it 0.01 thick. And we're going to make it as tall as the entire object. Okay. So we're going to put a rib here. And we're going to put a rib here. So that'll be 2 ribs. Let's see, center this way. Turn you transparent. Turn you transparent. Okay, that looks good to me. Join you together. So now this is actually different depending on what slicer you're using. I'm using Simplify 3D. Simplify 3D treats the outer perimeter of the drawing as the edge. So the how do I describe this? So Simplify 3D, if you were to draw an edge, Simplify 3D treats the edge of the nozzle path as the edge of the model, while Cura and Prusa Slicer treat the center of the filament path as where the model's formed from. So in Simplified 3D, I need a better circle. Here we go. In Simplified 3D, the edge of the model is 0.4 millimeters away from the drawing path. While in Cura and Prusa Slicer, the edge of the model is 0.2 millimeters from each side of the drawing path. So Simplify 3D draws the edge of the model like this. So any void space, the entire nozzle is inside the void space. That's the interior space where infill would be. While with Cura and Prusa Slicer, the center of the nozzle is the draw line, not the edge of the nozzle. So in Simplified 3D, I have to make sure my cuts that I make to make these reinforcements, I need enough space for the outer wall, which is 0.4 millimeters, and I also need enough space for this inside rib to reach the wall and turn around. So in Simplified 3D, the gap between your cut and the outer wall is important. While in Cura and Simplify, or Cura and Prusa Slicer, the width of your gap is important. Basically, your gapping has to be 1x your nozzle diameter for Prusa and Cura, while for Simplified 3D, the gap needs to be 2x your nozzle diameter. However, the thickness of your cuts can be 0 in Simplified 3D, since it treats the inside of the cut as the outside perimeter of the model, and they can be 0. While with Cura and Prusa Slicer, your gap, your cut gap, must also be 1x the nozzle diameter. So when I put this cut in the model here, I need to make sure this cut is 0.8 millimeters away from the outer edge of the model. The reason for that is, if this is the outer edge and my cut does this, well, as you can see, this line here, that line there is going to be 0.8 millimeters thick, because it's two paths. The nozzle coming out, turning around, and going back. Okay? Now, it has to have enough space to turn around and come back without piercing the outside edge of the model. So that's why I drew it like a square. Well, the wall is 0.4 millimeters thick, and this little tiny section of wall for the cut is 0.4 millimeters thick, so 0.8 millimeters. However, if you're drawing from the center of the filament path, all those are halved. The advantage, I like the Simplify way because I can make all of my cuts 0 millimeters wide, while with Cura and Prusa, you would have to make all of your cuts 1x the nozzle diameter. So the cut would have to be 0.4 millimeters thick in order to allow that path to be drawn by the G-code slicer. Okay. All right. Do I need to do anything else? I don't think so. Oh, I want to chop the top off. That looks more even. Yes, that's what it should be. So if you zoom in real close here, you'll see that slice doesn't quite go all the way to the edge of the model. That's so it can draw this path on the outside, and then when it comes back to do the inside, it just goes boop, boop, and comes back out again. This allows me to add structural reinforcement ribs without breaking vase mode. So vase mode is intact. Except one cut, this one right here, because this model goes all the way around. See, I have an outside surface and I have an inside surface. So this cut, this one back here, has to go all the way through. Now this one here doesn't have to go all the way through. That's why the cut starts up here, because this inside and outside surfaces are connected. Now the only problem is, I forgot about this. Well, this should connect when it crosses over to do the inside-outside. So that will be strong enough. But this surface here won't be. And this surface here won't be. I need to, I'm not worried about this surface. That's okay. We can ignore that. Yeah, we can ignore that. I'm not worried about that. That should print just fine. This one here, though, is going to be a problem. So, well, actually, no, it won't. It's angled. But I would still like to make this a little smaller. Now, the way to do that is to... Hang on. We put a surface here. We put a block here. Okay. And we make that block 2 times the nozzle diameter, 0.8. And then we put a plane here. Now what I have to do is I have to chop this face. But I don't want to chop it straight because that's not going to be strong. I want to chop it at an angle. Hey, tripods. So what I will do is now put a face back down here. Drop down one of these. Let's make this a little bit smaller this way. Let's rotate it. Stretch it. Rotate it 180. We're going to make this a cut tool. Alrighty. So now what I have to do is bring this into this, like this, until it touches that wall. Come on. Why can't I grab it? It won't let me grab it from the inside. Okay, now I can grab it, though. That should do it. Now, if I bring it down a little bit, I can probably get it a little closer. Too close. Let's turn off. Right there. So now if I chop that off the face, I can delete this. There. Now my face comes down to exactly 2 times the nozzle width. So it can complete this perimeter without having an issue. In theory. I should make it flat, but I'm not gonna. I think it'll work. I think it'll be okay. This is technically a problem right here. This should be an angle all the way down, but I think we'll be okay. I mean, I could fix it. Why can't I change the shape of this? There it is. That should do it. This is a crude way of doing it, but I'm getting rid of this top flat surface. There. That should be close enough to make this print okay. So we have our cut in the back to allow vase mode to work. If I wanted to do this correctly, this entire edge here would be 0.8 millimeters thick. So that when the 2 perimeters came together, they would touch. That's the correct way to do that. I'm not going to mess with it. Close enough. All right. I think that's enough reinforcement. Let's see what it looks like. Tipping cup. Let's see what it looks like in the slicer. I did not ask you to grab everything. You screwed up. Or did I have them all attached? I have them all attached somehow. Please stop doing that. It grabbed that when I attached them. Okay, now we got to give it a couple seconds to read the file so it doesn't flip out on me. Okay. Let's see, tools, variable settings. We're going to put a start point at 3 millimeters. Split the process. We're going to make this infill 20%. Let's do honeycomb full because it'll look nicer. Skirt's fine. No top and bottom. 0.24 millimeters is fine. Let's go to, yeah, 0.24 millimeters is fine. Three perimeters, that's fine. 0.95, that's fine. This is going to have also no top and bottom layers, but this is going to be single perimeter vase mode. And we're going to drop down to 0.2. And that should give us our model. Yes. Looking good. What we are looking for is retractions. So if we see any, you can see like retractions will look like this. These little bubbles, those are retractions. Now, during the first 3 millimeters, we want retractions because we're doing infill. That's the bottom of the model. But then once we get to here, we are no longer doing infill and we're doing phase mode. Now, the only thing I don't like this very much, but I think we can ignore it. Yeah, I think we can get away with ignoring that. And then once we're doing this part here, you can actually see the path here. So you can see the filament path there. Now this will actually touch the outer wall, which will tripods, which will dramatically reinforce this wall, make it much, much stiffer. This one goes all the way through the wall. That is to make the inside surface and the outside surface one surface, because it has to be one continuous surface in order to be vase mode printable. Now, what I could do is I could add a top layers. If we do 3 top layers, that should close in that top a little bit better. Yeah, that does look better. Here we're pretty good. You can see we're pretty close to touching. But as you can see over here, we're not. But that's okay. That's only the top 3 layers. And this will print in 4.5 hours. It's 200 millimeters tall, and it's only going to use 46 grams of plastic. So this will be strong enough while also being, I should put a rib on the front here. That front is going to be pretty floppy without a rib. Yeah, I better put a rib on the front. for a pair of ribs. So that is easy enough to do. Well, let's see, can we split this? Yep, that'll work fine. Split it again. That'll work fine. Split it again. That'll work fine. Split it again. And that'll work fine. So we're going to lift this 1 millimeter because I want that bridge across the front there. Okay. We're going to, oh, I don't want to lift it yet. I want to duplicate it. Then I want to lift it. That. Then I want to flip it. Then I want to hide it. All right, let's merge all this together. Now unhide it. Okay. Not what I want. So we need to put a surface here. And then we need to go, oh, come on. Negative 0.8. Okay. Let's put this over here. Bring this over here. Okay, take this one and this one. Join them together. Now let's center them. And join them. Okay. Now we have 2 ribs on the front as well to reinforce that front a little bit. They could probably be closer together. So let's bring them closer together, rejoin, center, and join. That's better. So now we have 2 ribs on each wall. That's better. I like that. Now the ribs don't go all the way down. I'll show you. See, the ribs don't go all the way down because I need this bridging to occur. So if I had them go all the way down, it would attempt to do a wiggle while it was in midair. So I need this to be a clean bridge. I also need to get... Ooh, that curve is going to be a bear. That's not going to work. Ooh. That's going to be ugly. That's going to be real ugly. I need to make that inside wall straight. Can I do that? I mean, this should do it. I don't want you to move. So I should be able to center it this way. But I can't center it this way because I need to use a face. I should be able to do this. Now that should be centered inside. Now I should be able to turn off the radiusing. And that should allow me to cut. So the outside will be curved, but the inside won't be. Yeah, see how it cuts it? But that's a little too close, I think. I only need to cut the bottom. I just need that bottom to be squared. But is that going to come too close? Let's try it and see. Well, let's not. How about we not cut the bottom? Because I think that's going to break some things. Let's see what that does. Yeah. See how it's straight now? Let's see what that does. There. Clean bridge. That's what I need right there. Okay. That should work a lot better. Okay. Now you see we have the two. That shouldn't be overlapping like that. I wonder why it's overlapping like that. I keep forgetting the damn keys are backwards. It's maintaining vase mode, so I'm tempted to leave it alone, but that looks like it's too close there. Instead of like this way it should be. Oh, I know what I did wrong. I went 0.8 millimeters in and not 0.8 millimeters from the outside wall. Okay. Stop it. It's so hard to manipulate sometimes. If we take that apart and we take that apart. Yeah, I screwed that up. So this face, to this face. This needs to be wrong piece. There we go. 0.8. Why do you resist me? There we go. Now that should do it. I don't need that anymore. Hey, everything I've made, I've used Tinkercad to make. So I'd say it's working pretty good. Lol. Let's see. That's better. There's the proper gapping. Okay. In theory. You just got to make the the two faces a single face. That's all. If there is a way I could use a proper CAD program and make that a universal constraint for adding ribs, I'd do it in a heartbeat, but no one's figured out how to do it in an automated fashion yet. No one's figured out a way for me to put a cut plane inside of a model and say maintain this distance from the outer surface. No one's figured out how to do that yet. So I have to do it manually. Well, that's the cool thing about the one of the reasons I prefer this is just because of what I'm doing. I like the way Simplify 3D does it with the outer surface. The gaps are irrelevant. So Simplify 3D. So think of this as being the two nozzle paths. Okay? Simplify 3D treats this edge where the two nozzle paths join together as being the outer surface of the model. And because of that, when I put a cut in a model, I can make the cut 0. The cut can be 0 millimeters. I actually make it 0.01 millimeters just because you can't do a 0 millimeter cut. But the actual spacing of the cut doesn't matter. The spacing that does matter is when you have your rib. So this here. So as you can see, I keep forgetting it's reversed. So you have this rib here. Now, there has to be physically enough space for the nozzle to draw that path. This little space here can be 0. But this space here has to actually have a width. Because remember, Simplify 3D draws from the outer edge of the model in. So the entire filament path. Okay, so when you draw a shape, you have the outer edge of the model, which is this. And then you have the void space, the interior space that makes up that shape. So on the screen here, hang on. I need acid. So right here. So here's a square. Now you can see through it because I turned off the top and bottom layers. But here's a square. All this space where you see the hexagonal infill, that's the void space. That's the interior of the model. So that's solid. Okay, there is no hexagons there. That's all solid. We are simply instructing the slicer, okay, fill the void space with a hexagon pattern so that it's stronger and doesn't take a million years to print. So a model has, let's see a good way to describe it. So an opening doesn't have any void space. The void space is the difference between the inside wall and the outside wall, that thickness. Inside that, the interior space is the void space. Well, the problem with vase mode is it has to be one continuous path. And you can't do a continuous path with a hole because you have an outside surface and you have an inside surface. So the cut is the easy part. God damn it. See, in Tinkercad, the middle click is to drag, But in Simplify 3D, middle click resets your view. While in Simplify 3D, the right click is your drag. Really annoying. So what I've done is I put a slice in the wall to connect the inside surface to the outside surface. So it's like a Mobius strip. It's one continuous surface now. So now the slicer can actually calculate a path. I just did it. All I do is I just slice the model. See? See, I have these little 0.1 millimeter. Well, it'll look like this. Now, this one you can see it because it's transparent. So you can see there's the ribs. So this one goes all the way through. But these don't go all the way through. They only exist on the inside. So on the inside, you can feel the rib. But on the outside, it's just smooth. So if I did not use a transparent plastic, you wouldn't be able to see those ribs. You can actually kind of see this on this model. No, you can't. That model, I got rid of I don't have the ribs on that model. I have a model with the ribs. Make it easier for you to see. No, I don't have it handy. But this is that model. So the trick is figuring out the spacing. This is easy because it's flat. It's straight. It's a straight shape, so figuring out the gap is easy. Now, when Simplify 3D draws a box, the outer edge is the surface, and the inside is the void space. Now, when Simplify 3D calculates the edge of a model and it draws the filament path. Remember, your filament path is made up of a 0.4 millimeter flattened tube. So you have a 0.4 millimeter nozzle and you have the lay. That's the filament lay when it extrudes 0.4 millimeters of plastic out of the model and then smears it. It's basically drawing a 0.2 millimeter thick log that's 0.4 millimeters wide. Now, in Simplify 3D, I need a bigger piece of paper. Where is a piece of paper I can use? I'll use a box. So, remember, here's your surface. So you have your box. So this is your outer edge. This is your void space. Simplify 3D, your nozzle path exists inside the void space. So the outer edge of the nozzle touches the outer surface, the perimeter of the model, and the entire filament lay path exists inside the void space. However, Cura and Prusa Slicer don't do it that way. They do it this way. They draw the draw path directly down the center of the nozzle. And then, of course, they shift the nozzle 1/2 the nozzle diameter inside the void space. But the actual, so think of it this way. How do you describe it? So, if this is the perimeter of the model, Simplify 3D draws it like this. So it draws it with the entire nozzle inside the perimeter of the model. Prusa and Cura don't do that. They move the pathing of the model. The result is the same, but when you make the cuts, it changes how you make the cuts. Because of because Simplify 3D does it this way, my gaps can be 0. And I just have to make sure when I do ribs that the ribs are so when you do this rib has to include the thickness of the outer wall, which is 0.4, and the thickness of this leg right here. Because when the filament path comes out to draw the rib, it can't just go back, because it'd be going back on top of plastic it already laid down. So it has to move down with this little dog leg here in order to be able to come back this way. So it has to create this little box. Now the gap here is 0. It's actually 0.1 millimeters, but it's 0. This gap is 0. But the gap from here, from this point right there to this point right here, has to be accounted for with my rib. Now the reason I like this so much is that it's just 2 times the nozzle width. I can make the ribs 0 millimeters thick, and I just have to space them 2 times the nozzle width, because you need enough space for this path and enough space for this path. And these 2 paths together equal 0.8 millimeters, because it's a 0.8 millimeter or a 0.4 millimeter wall. Now with Cura and Prusa Slicer, it's different. Because Simplify 3D performs its calculations based on the edge of the filament path. That's why this can be 0. Because it's calculating, okay, here's the edge, I go 0.4 millimeter this way. Here's the edge, I go 0.4 millimeter this way. Therefore, I can make this gap 0. But with Cura and Prusa Slicer, they calculate the filament path from the center of the filament path. So it's 0.2 millimeters this way and 0.2 millimeters this way, as well as being 0.2 millimeters this way and 0.2 millimeters this way. So this gap has to be calculated from the center points, not from the edge. See, the edge makes it easy, 0. And when you do a gap, double. But because Cura and Prusa Slicer calculate from the center of the filament path, you have to account for the gap. Because if I make this gap 0, it's going to put the filament path here, and you're going to have a collision. You're going to have 2.2 millimeter filament paths overlapping. So I now have to make that gap big enough to account for half the filament path on this side and half the filament path on this side. So all of my little cut planes would have to be 0.4 millimeters thick, and then it would fill it in by calculating from the center. That also means this filament path can also be half. Matter of fact, it has to be half. If you make it double like I do, but print on Cura or Prusa Slicer, you'll actually have a 0.2 millimeter gap between the rib and the outer wall. And if you have your printer tuned correctly, that gap will actually be there, and you'll see, like this here, I can twist this and it's solid. But if you were to print this model with Cura or Prusa Slicer, then when you twisted this, those ribs might actually separate from the outer wall. They might not actually be merged. So you're just making the wall toward that thick. I don't know what that means. So usually when I upload a model like this, I'll include G-code, so that if you're not using Simplify 3, it'll still print correctly. Now, you could probably get away with that using thin wall behavior. That might be enough to compensate. Also, if you're doing vase mode, just over extrude a little bit. So instead of printing at 0.95, print at 1.0. That little bit of over extrusion will probably be enough to fill that gap and make sure those parts touch. But if you do it right, if you slice it right, you end up with that nice smooth outer wall, and the ribs aren't visible. If your slicer is tuned correctly, If it's printing correctly, you shouldn't see the gap. You'll see the ribs on the inside. So if you go on the inside, you'll be able to see the ribs because, you know, obviously it actually drew a rib there. There's no way to make that invisible. But that's how I can make ultra complex shapes like this that have actually an inside, an outside, inside, outside, holes, launch slugs, everything. And this whole entire thing prints in vase mode. This is all vase mode. And that includes making sure the top edges of these fins are exactly 2 times the nozzle width so that it can draw them like that. Because otherwise you'll have a gap and then this won't be strong. Like you see here, this one here got a little it's a little floppy. Okay, and it's also floppy this way. It's strong, but it's floppy. So on the final model, I put a rib right here connecting these two sides, making this super rigid. And then I also put a rib right down the middle of the fin here, which makes the fin straight so you don't get that waviness because there's nothing holding the plastic. So the final version of this is nice and strong. And you can just see that rib because it's technically there. There is a rib there. But again, the more properly tuned your printer is, the more invisible that'll be. Okay, that should print clean. I don't see any retractions, so I didn't break the perimeter. It's not broken. The printers I mostly use are my Ender 2s, my Ender 5s, my 2 Sapphires, my CR6 SEs, my FL Sun, and my Artist D. Those are the ones I'm using most right now. What printer I'm using most just depends on what printer I've, currently have sitting on a table somewhere. I have limited table space, so I can only have maybe a dozen printers. Not even. Let's see. 1, 2, 3, 4, 5. Yeah, about 12. I can't run 12 printers, but I can have 12 printers accessible. So if I'm printing something big, I'm using the Chiron. I have a modified Chiron one. It's not really modified. The only change I made was to put a 1.2 millimeter nozzle on it. Oh yeah, I wanted to see how this printed. Yeah, that looks good. I can live with that. That should provide enough rigidity. This is all goofy, but that's okay. I mean, it's just holding sauce packets, so it's not like the end of the world. Okay, I can live with that. Yeah. This shouldn't have retractions here, but, I don't care. Okay. When it gets to here, the retractions stop, and you get nice, clean vase mode all the way up. And that's all that matters. I mean, I could spend the next 2 hours fine-tuning the model to make it perfect, but there's no point. So the printers I currently use the most are the WeDo right here because I got the 1.4 millimeter nozzle on it, the CR6 SE, the Hornet, which I got to change the interior PTFE tube. I think the wood filament scratched it up too much. The Sapphires, when I'm doing a whole bunch of something, I bring up the Sapphires. The Ender 2, the Ender 5 gets a lot of use. It's just, it's whatever I currently have sitting on the table and plugged in. I don't really have a preference for what printer I use. All of my printers work fine. So I'm going to get basically the same results out of all of them. So I'm not too picky about which printer I use. It's that one's plugged in. It's not running. Okay, I'll use that. Yeah, it's just whatever's sitting there ready to use. Yeah, I'm okay with this. This looks good. Now, one trick with doing this, you cannot scale these models. So I can't scale this. If this was a normal print, I could simply make this wider and make it narrower in order to make it hold this. Okay, I can't do that because if I scale this model more than like 10%, these gaps start to break. So for example, if I were to scale this front to back, well, that's okay for these gaps here, but that's not okay for this gap here because that's going to make the gap between here and here smaller, and then you'll break vase mode. You can do it to a certain extent. You can get away with it because you have thin wall compensation. So thin wall compensation will work to a certain point, but at some point you're going to exceed the limits of thin wall compensation and you're going to break it. It's usually right around 10%. So if this model is like 3mm, needs to be 3mm wider, I can get away with that. I can stretch it 3mm and it'll still work fine. But actually, I can show you. So let's say, for example, I make this model smaller. Make it smaller and make it wider to hold the sauce packets. How much can I get away with? Hey, 3D print creator. Okay, see how it starts to break it? See how it's popping through the face here? Actually, that handled it surprisingly well. That's still valid vase mode. I'm surprised that worked. I'm surprised it let me modify the model that much. That's actually really impressive. That shouldn't have worked. I guess we're within the tolerances, and it let me do it. Wow. Oh, but see how we're starting to. This is where you run into the problem. See how you have an actual gap here now? So thin wall was able to compensate here, but you see now how it overlaps? So it's saying, okay, I'm going to draw that path, but this is going to overlap, which means you're going to have a visible bulge on the front of this model. Now, for something like this, that doesn't really matter. It'll look a little uglier, but it'll work. So the reality is you need to go back into the program and redo these. Because otherwise these gaps are going to be too big, which means these ribs won't actually connect with the outer wall. Well, my my slicer is tuned pretty well, meaning these ribs are actually connected inside and out. That's why when I twist this, there's no cracking because that's actually connected. If I tried to print that and I did this, those ribs would crack, and now you'd have an outside surface and an inside surface, and they would not be connected. It would print fine, but it would be weaker. The rib wouldn't actually be making it stronger. Yeah, it's amazing what you can get away with in 3D printing, where it'll just be like, oh, I'll still work. That's okay. And it's like, really? That's amazing. But you would also defeat the point. It would no longer be a structurally stable model because you broke the you broke the ribs. The ribs no longer function correctly. It'll also be uglier. It'll work. It'll print, but it'll be weaker and it'll be uglier. And I like pretty. And the cool thing about 3D printing is that, yeah, you got to put in the extra work to make the model pretty. But you only have to do that once. Once you do the work, that's it. Click, print, click, print, click, print, click, print, click, print. And it just keeps making it over and over again, perfect every time, if you put in that little extra work that first time. So I don't mind putting in the work. See, like this here, this should not be rounded. This should be square. So that's going to mess up a little bit right there only because I'm printing in vase mode. In regular print mode, this would work fine. But because I'm in vase mode, that's a little problem. But only for a couple layers, and it's only 3mm thick. So I think I'll get away with it. When I look at the slice, it looks okay to me. So this here won't be a curve. it'll be a straight line from here to here, and there'll be some droop. But after about 2 or 3 layers, it'll build on top of itself, and it should be fine. This one will actually be even better because that's weird. They're angled here, but straight here. So that right there, if you know 3D printing, and I know you do, you know that's not going to print correctly. This is not possible. But it's going to be so minor, you're never going to notice it. I mean, we're talking about, this is like 1 millimeter. So it'll be okay. It'll be fine. We don't have to go to the nth degree for that. This would help if I did that. There we go. So I'm totally okay with that. You see, it's a lot cleaner in here now that I got rid of the curve. So that interface is a lot cleaner. I'm okay with that. Yeah, that looks fine. I did the hexagon just because it looks nicer. As you can see, when you do something like this, the hexagons just have a nicer aesthetic. There's no other reason, it just looks nicer. All right, good. I'm happy with this. Let's make the one for the packets. Okay. No, the infill is not vase mode. The first 3 millimeters of the model are not vase mode. I need that base to be nice and strong. So, for example, when I printed this model here, you know, that's not vase mode. That's just a print without top and bottom layers. Same thing here. The bottom 3 millimeters is regular. The top 3 millimeters is regular. Everything in between is vase mode. Simplify 3D allows you to switch back and forth between normal layer by layer and vase mode. You just use multiple processes. So if you see my Simplify 3 here, I have 2 processes. So this process 1 is the first 3 millimeters. That's normal print mode. Process 2 is the rest of the model. That's vase mode. So this is just normal print mode, but I've turned off the top and bottom layers. And this is single perimeter vase mode. So Simplify 3D lets you do that. To really do this properly, the slits should stop 1 millimeter from the top, or 1.5 millimeters from the top. And then I should have a third process where I switch back to regular mode. But I don't care. You're not going to notice that. It's a goddamn condiment holder. So I don't have to be that perfect. So I'm totally okay with that. Technically, we're going to have an issue here. Okay, actually, I can just slice it. So here I worried, because that's structural integrity. If the vase portion of the model doesn't connect to the base of the model, it could fall apart. Well, I still prefer Simplify 3D just because I know how to use it. I know how to bend it to my will and make it do what I want to do. It's nothing to do with it being superior, although I do think it's slightly better in some ways. It's not about it being superior. It's just about my preference. I know how to use it. Will I promote it? No. Will I suggest anybody buy Simplify 3D? No. Well, why would you buy a dead slicer that's not going to be updated? The probability of us getting a 5.0 is basically 0. So I can't in good faith suggest to somebody buy Simplify 3D. Now, if they like doing what I like to do and money is no object and they can afford to throw money at it, okay, great. Buy Simplify 3D. You will like it. It's a good slicer. But for a new user, no. I wouldn't suggest Cura. I'd say go with Prusa Slicer or Idea Maker. Now you can see this is going to be a problem right there, where I made it go from straight to curved. Whoop. Right there. That's going to be a problem because that's not possible. You can't do that. This is just going to be a straight line and a droop. But after about 4 or 5 layers, that will that will eventually, by about there, that will connect and be a curve. So why don't I care? Because it's non-structural and it's on the inside. So you're never going to see it. You're never, ever going to see it, so I don't care. I want most of it to be curved because then your sauce packet is also curved, and your sauce packet's less likely to jam inside with a curved surface. But the bottom I want to be straight because of this interface, printing vase mode. If that interface isn't clean, you could have a problem. But beyond that, once you get past this wiki part here, then I don't care. I go back to the curve, so it's fine. All about compromises. Now this, I'm wondering, I could... Hey, is there... Oh, yeah, I didn't... I can duplicate this and scale it simply because I can move the slices. So I can do that, and I can get away with it because I can move the slices. That's a hell of a bridge, but it should work. Worst case scenario, I cut away a couple of the droopies, but that should work. I do want this to be fatter because I want to be able to fit more packets in here. So for example, I can make this a bit fatter like that because I want to be able to stack up packets in here. So I'm okay if they overlap a bit. I want to be able to fit more packs of sauce in this one. I just need it to be wide enough to make sure those packets lay down flat. So there, I've got it roughly the size. I think I need to make this opening a little more because unlike these, which are going to sit like this, and I'll be able to slide one out without a problem, I think I need to have an arc here or a triangle here for my finger to be able to get my finger in there. I mean, I could just make it taller because that is enough for two. So the easiest solution would be to simply make it taller and then chop off the top. That would work. But you don't want too many coming out. I just can't promote a dead product to people. Even though Simplified 3D does not require any updates, it works fine. I mean, 99.9% of everything you're going to print will work just fine on Simplified 3D. It is already so superior to the other slicers that it doesn't need any more updates currently. It's when you start doing weird things like I do that you run into these little bugs. You run into minor issues. I'm going to have to change the height of this as well. Or do I? Let's go to 0. Then let's go back down to here. Now, where am I? I'm at 3.53. So if I make this 0.53, I should be able to chop off the bottom of the model and get back to my 3mm thick floor. Okay, let's get this out of here. Oh, I thought that would be a problem. Get rid of you. Nope, you stick out far enough. You're good. Now, I have to correct my slices. I don't have to correct this slice, because that slice is fine. But I do have to correct all of these other slices. So I should be able to simply break apart the model. There we go. So I should be able to hide the parts that I don't want to. Let's just delete that. We don't need it. How can I successfully hide these? Yeah, I can just lower this below those models right there. Okay. So this one I can leave, but these need to hide. I need to hide you. I need to hide you. And I need to hide you. Okay. I should be able to select everything else and join. There we go. That will work. Now I bring my models back. So this model is now 113 millimeters wide. I need this to be 1.6 millimeters less than that. So first, let's join these two together so I don't have to keep fighting with them. Now, 1.6 would be 112.4, 111.4. So 111.4. And now we center everything. Okay. Now I need to space this one correctly. So to do that, I put the face here. I put a box here. I change the face to this side of the face. Then I grab this. Oh, wrong one. I grab this one. And then this needs to be. Wait a minute. No, it has to be this face. This face right here. And now I go in negative 0.8. Negative 0.8. Okay, now all my spacing is back to the way it should be. That's for these sauces. So, for tubs and for packets. I'm designing for the largest packet since that's the biggest packet I have. So these should work inside of the bigger opening. And the tubs appear to all be the same size except height. Oh, God damn it. It's staying there now. Oh, I can get it. Pick it up. The honey and the are the same size except one's twice as tall as the other, so I'm just designing for the bigger one. And it should be close enough. Okay. Let's delete my little tool. Put this back down here. These should now be properly cut. Yeah, I think that's good enough. That should do it. Now let's get rid of something off the top. Okay, did I clip the bottom? Yes, I did, I think. I think I clipped the bottom. I'll have to double check that. Actually, it doesn't even really matter. Let's do this. Whoop, right like that. Like that. Sauce packets. So salsa, horseradish sauce, and Taco Bell sauce. In reality, the Taco Bell sauce one should be smaller, but I think it'll work fine. We're going to try it. If I have to, I'll make a custom one for the Taco Bell. And then for tubs. I actually want my drawer back. I'd rather have the sauces in a box underneath the counter and then fill my dispensers up when I need it. Because I'd rather have my drawer back for tools and utensils. That's right. I need to do this. First, let's make sure this is at 0. So let's put this at 0. Let's make it the same height as this one. Which means we then put this at 0. That's incorrect. 0. Then extend. So it's the same height. There. Now they're the same height. But this one's for sauce packets. This one's for tubs. I could probably make a double tub. That's actually not a bad idea. I try not to have too many on hand because I don't know what the shelf life is. I do know that over time this plastic will break down and start to make it taste funny. Like you leave soda more than a year and it tastes funny. More than a year and a half and it's downright bad. So I don't know what the actual shelf life of this stuff is. So I try not to keep more than 6 to 8 months of it on hand. Or I just intentionally use it up when I think it's it's getting a little long on the tooth. Okay, so I want to make a double one. Just because I think it'll fit. And it'll take up less space. And I think I could print it all at once. On little packets? There might be a date on the box it came in, but not on, here in the US, the little packets don't have dates. Now, something like this will probably last quite a long time because it's acidic. Something like this will last a long time. Again, it's acidic. Same with the hot mustard. Okay. Salsa, it's tomato, so it's acidic, but it's not that acidic. And also, honey should last forever, in theory. So it depends on what it is. So now I wonder, is it as simple as put them together? Mayonnaise, yeah, I figure mayonnaise would be pretty short-lived. I try not to keep too much of that on hand. Ooh. I wonder. This might be as simple as getting rid of let's hide this. Let's hide this. Let's take this. I want these to be joined together. Now, I think I can just shrink these. McDonald's mayonnaise is good for 12 months. These little packets of mayonnaise is good for 12 months. That's pretty awesome. I wouldn't have thought it would last that long. Now, I don't need 2 all the way through slits. I only need 1. Why isn't that working? Oh, I have grid off. I think that would work. Now, there are some complications. So I need to hide this. Oh, now that's interesting. Okay, I think I know how to fix this too. Okay. So Control D again. Give me a third one. And let's do another Control D so I can keep a single handy. So there's a single, there's the packet. Oh, that's all right, Vaughn. Don't worry about it. Make sure you mess with the bell settings. Because it'll adjust what you see based on that bell settings. So you can subscribe to a channel and see it less often by adjusting the bell settings to never, or see it more often by setting it to always. That's what the little bell does. Because once you add a certain number of subscriptions to your channel, it has to pick and choose what to show you. And, well, the algorithm might decide, oh, I don't think he wants to see this one. So a little annoying, but, you know. Okay. So let's see. What can I do here? First, let's make my little thing I want. Let's do this and this. And let's do all the way up to the top here. Like that. You'll see what I'm going to do here in a moment. This ought to be pretty interesting. We're going to do that. Actually, yeah, I'm going to leave that rib there just because that rib will make it stronger. But I don't want that rib on the bottom. So I should be able to do this. Then I should be able to take this, Control D, like this. There. And then do this. And then bring this over here. Bingo bango. Oh yeah, now we have a solid bottom. Ha ha! Okay. Now, I no longer need this rib to be in the back. I could put this rib here now. This is going to be 0.4. This is going to be a 0.2 millimeter layer height and a 0.4 millimeter nozzle, just so it could be printed on any printer. Okay, I'm liking what I'm seeing so far. Now, can I do this? Let's split this. Let's split this again. Well, first, let's hide this. Hide you. Hide you. Split you again. I want to join all of this together except for this. Okay, bring everything back. And now we're going to rotate this 90 degrees. And we're going to plop it right here in the middle. That should work. Okay, but now I need ribs here. So let's Control D. Rotate 90 degrees. Should need to rotate 180. There we go. Okay. So Control D. Not what I wanted you to do. Okay. So now we need reinforcement ribs on the back. That looks good to me. And then Control D and D. I think that'll be good enough. You and you and you join together. Now let's center all of this. No, I can't do that. I think I have to first do this. Join. Now I can center it on this. No, I didn't want to do that. Yeah. There we go. I want to center this just a little bit. Okay. Now I need to put a face here. Move this to negative 0.8. Come on, cat. You weirdo. Okay. Now we join. Yeah. Okay. So, inside here. Oh, I need an outside one too. This will connect this to this. Back to this. Back to, okay, that does the inside, but not the outside. So I also need a slit on the outside. Come on. What the fuck, cat? Putting his damn claws through me. Okay, so I also need one of these I do have to cut to the outside. And I'm just going to have to put it in an arbitrary location. So close to the center, that's fine. Hey, John. Gridfinity? It hasn't been. I know what you're talking about, though. Okay. So this requires 2 cuts since we have 3 surfaces to connect. We have this inside surface, and this outside surface. So in order to connect them, I have to have 2 straight through cuts. These are just ribs. These are all the way through. So now if we start here, we can go around the inside, cross over to this inside, go around the inside, cross over to the outside, go around the outside, back to the inside, back to the inside. Okay, we're good. So that is a double tub. I have a little tiny wall that where my fridge goes, and instead of just being open there's a little tiny section of wall, and I'm thinking these little containers will mount perfectly to that little tiny thin wall. So that's why I'm making them like this, so I can just mount them up with that length of wall there. I probably have more ribs than I need, but it doesn't really add much print time, so why not? Now, what I did do is I got rid of, you see here, I have this little bump here separating the two because they're rounded. Now, that actually adds reinforcement here, but it causes problems for my bottom layers. So by grabbing that bottom piece and merging it, you can see I got rid of that. I made it one big foot. So that's why I grabbed that section and merged the 2 of them together for that section. Okay, let's download that. So wait a minute. So we're going to call this one Double Dip. Double Dip! Okay. And then call this one Sauce Pack. Export. STL. Let's see how they slice. So that one slices good. I might as well actually slice it. Save the G code. Okay. Save the factory file. Now, because I kept the foot the same size, I should be able to use the exact same factory file for each of them. For the same slicer settings. Oh, it is going to break it in the center here. This center cut needs to go all the way down. Wait a minute. Okay, that is, I mean, right now it'll work. You'll just have retractions. Or will it? That shouldn't work. Oh yeah, because the front's open. And it can get in between. Yes, we're fine. We're good. Ooh, that looks nice. Hot damn, that actually looks good. Yep, we're good. We're all connected. Damn it, that looks good. Oh, I like the double dip. And that whole thing prints in 8 hours. Not freaking bad. Are you trying to bite him? Huh? Aren't you nice? Try to bite him in the butt. All right, I like that. That's awesome. So that one's called Double Dip. And save factory file as it should be Double Dip. And now let's slice the sauce packet version, which is just a real big one. There we go. It's clean. I don't see any issues. I wouldn't expect to, since I corrected all the gapping. Yeah, see how the gapping is correct now? It's all good gapping. All right. Let's copy that so I don't have to retype it. Save. File. Save factory file. Sauce packet. Okay. Awesome. I'm actually kind of excited to print these now. I could probably make that hex pattern quite a bit bigger. It does not need to be that dense. Infill, let's go 12%. Yeah, that's much better. Hell, I can even go down to 10%. This is purely for aesthetics. I just think it would look nicer with bigger hexagons. Yeah, I like that. That looks good. Let's see. We are going to save sauce packet. Let's do the same thing for the double dip. Yeah, much better. Looks better with the bigger hex. Double dip. And I'll leave the single dip as a 20%. You can see the difference. I am pleased with this. I think it came out nice. So now I could put either two of the same or I could put two different ones on there. So I can hold twice as many. I made it 200 millimeters tall, so it'll print on pretty much any printer. Now, if you want to get really cheeky, you know what I could do? I wonder. There's a little trick you can use to make this a variable height model. No, the max height of these printers is 250. That's why I'm doing 200. So that if their bed is unusually thick, if I make it 250 on a 250 printer and they made their bed 5mm thicker, well, it's going to slam into that top end stop there. So yeah, I'm 20% under the max height of the typical printer this is going to print on. Now, there is something a little cheeky we can do. It's a little sneaky, but it does work, I think. Let's do it. I think the only one I would need it on is the tubs. So the trick would be to duplicate this, raise it up, and chop off the bottom. Okay. So if we take that, and we join, it'll take a while because it's got to do a lot of recalculating. There. So now those are identical all the way up. So let's call this DD extension. And the origins should be the same. You got it, 3D Print Creator? We're going to be ending soon. But I got a little trick I want to try. All right. Now, in theory, I should be able to drop the extension on here. I should be able to align model origins. Yes, that worked. So now I can change the Z height of this to whatever I want. So the Z offset, let's go 100 up. That's too much. So we want them to overlap a little bit. There. Now they overlap. Now I can print this to any height I want and simply instruct the slicer to stop. So we're going to go into this first process and tell it not to print the extension. Second process will print the extension. Okay. Now the trick is we tell it to merge and heal. And now I can simply tell this second one, stop printing at 250. Bingo bango. It works perfectly. You can see there's no break. It looks like it was designed to be 250 right from the get-go. How cool is that? So I think what I need to do is to redo that again. Except I need to bring it up higher. Way higher. Right about there. Stretch this out so that we're some stupid 400 millimeters, 500 millimeters tall. Okay? You'll see why in just a moment. Yeah, 475 millimeters tall. Now we save the DD extension again. Here's what you do. Let's say, well, we can make it any height we want. So we drag the extension in here. We select them both. We go align, selected model origins. Okay. So now I have 475 millimeters tall. So let's say I'm going to print this on the Chiron, which has a 450 millimeter build height. So I just change this to 425. I'm just instructing the slicer to stop printing at 425 millimeters. And then I just make sure I tell it to heal, to merge the outlines together into a single model and heal them. Now, this might stop at the height of the print volume. No, it didn't. There you go. So now if I have a 425 millimeter tall build volume, I can do that. And as you can see, they're perfectly merged together. Oh, yeah. So now you can make this any height you want, from 200 millimeters all the way up to 450 millimeters, 475 millimeters. And you can go even further if you're crazy enough. If you have a printer tall enough, all you got to do is change the length of this part, turn off uniform scaling, and just start increasing the height. See? Just increase the height to whatever the hell you want. All right? As long as these two parts overlap, and as long as you align model origins, you just tell it how tall you want to print. So let's say stop at 550 millimeters. And then I also make sure I have this option selected. Slicing behavior, non-manifold segments, merge all outlines into a single solid model, and heal. That means it's going to get rid of the parts that overlap, making it into a single model. I assume there's a setting somewhere in Prusa and Cura to do this. But there you go. Now it's 550 millimeters tall, and it's still a perfect vase mode. How cool is that? So now you can make this little sauce packet dispenser any height you want. That's just cool. Now, the reality is I could design this model to be 600 millimeters tall, and then you simply tell your slicer to stop slicing at a certain height. I don't know if that works in every slicer, though. Do other slicers let you do that? So, for example, if I want to make a 100 millimeter tall one, I just tell this, 100 millimeters. And it will simply make me one 100 millimeters tall. Do all slicers let you do that? Like, do you have a stop at height? And it'll actually finish the model. So it'll actually put the 3 top layers on as if this model was only 100 millimeters tall. I'm not entirely sure if all printers will let you do that. All slicers. I know mine can, but I don't know if any slicer can do that. But that's just one of the little tricks you can do with 3D models and Simplify 3D. I have to assume all slicers can do this. I don't know how to tell them how to do it. Here, you select both models. You go to Align Selected Model Origins. Okay? And then in your last process, you simply tell it how tall you want it to print it. Okay? You want it 150 millimeters tall? You just tell it to make it 150 millimeters tall. And it will simply make the model, it'll simply stop printing. There's another 400 millimeters of model, but I simply told it, I want you to stop at 150. And it did it. So I don't know how to do that in other slicers. He's hungry, Michelle. She hasn't fed the cats yet. They're getting upset. They're like, come on, we're hungry. All right, I'm going to go feed this to a printer. Because now I really want to print some of these out. Especially this double one. So, for example, I can go 225 millimeters, so I might as well. Actually, I could probably get away with 240. 240. Oh, I bet you. Well, what is a CR6 SE build volume? Excuse me? It is 250. So, I can get away with 240. No problem. I could probably get away with 245. So let's go to 245 millimeters. And now I can print this at any friggin' height I want. There you go. Save as. So double dip 245. Let's get rid of the space. And it'll take 10 hours. That's no big deal. I could probably go a hell of a lot faster. I'll probably crank up the speed to 200% and print it in 6 hours, 7 hours. Because once you're doing the vase mode slice, you're good. But there you go. That is awesome. And it looks good. With those ribs, that should be nice and strong. I have my cut here and my cut here to connect all 3 outer surfaces into one single surface. Sweet. That is cool. Now I might eventually put a little holder on the front here so that you could take I can even see, taking one of these covers and laminating it, and then cutting out the lamination, and then turning that into a little card that you could then stick in a slot on the front here, or just design my own. Design my own little 3D printed cards that'll fit into a slot on the front here, so that you can tell what sauce packets is in there. That's something else that would be pretty easy to model. Yeah, that actually would be pretty easy to model in. Model in a little holder to yeah, I'm happy with that. I'm super happy with that. Now I could also just make a super long one for people who have the ability to print to a certain height. 475. Let's just go like some stupid. Oh, that's actually too tall for the. It won't let me go that tall. Interesting. So the tallest I can go is 500 millimeters. Okay. So if I simply merge these, and as long as you can assign a print to height in your slicer, DD super tall. Yeah, that would actually be easier, just to have a super tall one. Then you can define a print to height. Now, if your slicer allows you to merge, but doesn't allow you to define a print to height, then the extension will work, because you can simply define the height of this extension. Since it's consistent all the way up. So you can't scale this on X and Y, but you can scale it on Z as much as you want. So if your slicer doesn't allow you to define a print height, then this would be a problem, but this wouldn't, because I can adjust this to whatever height I need and then let the slicer merge them. So I'll leave both in the package. Cool. Very, very cool. I am quite happy with how that came out. Ooh, there is one issue. That's going to be a little messy right there. Oh, not too bad. Let's see what that looks like. It's a little messy, but it's not too bad. It does make a definitive break right here. See, straight edge, straight edge. That's the important bit right there. And then it does the straight across bridge. So these first couple bridges might be a little messy, depending on how well your printer handles bridging. So after a few layers, it's going to connect and you'll be fine. At that point, just snip off the dangly bits. So I am willing to leave that alone. I'm totally okay with just saying, screw it. It's fine. Yeah, I'm okay with that. I think it'll print okay. Yeah, I think it'll print okay. I would not go below 0.2 millimeter because bridging tends to get a little uppity when you go with thin extrusions. It tends to tear and doesn't properly bridge. So I would not go below 0.2 millimeter, at least until after the bridging. Do this section at 0.2, and then if you want to go thinner, that's fine. Similar with going thicker, I would stick with 0.2 to 0.24. I wouldn't go 0.24 on this though, not enough here. What I should do is put a triangle here. If I really want this to bridge properly, I'd put a triangle here so that it could work its way out on each side. But I think that would just look uglier. I think you're better off just taking the 1 or 2 layer hit down here, which you can just snip off. I think you'll end up with a better result. Now, the only problem is, did I make this tall enough for me to get my finger in there? Like, the honey will be fine, but the regular packet, I might need a divot here so that you can grab that lip and pull it out. I forgot about that. That might be important. Hmm. Like the packet one will be fine. Putting honey in it will be fine. But doing the normal height one might be a problem. We'll have to print it and see. But I might need to put a divot in there. I'll show you what I'm talking about. So that would be something like this. There to there. And then that might actually be necessary. That might be important. Okay, that needs to come down just a hair. So Control D, bring you over here to do the same thing. You don't want to break the surface. Shrink you just a hair. So that. D, join that together. Oops, it did not want to, I don't know what the hell I just did. What the hell did I just do?
What do you mean?
I don't know, I did something.
Get off the screen.
I somehow selected everything. Oh, there it goes. I somehow selected a whole bunch of stuff. So you might need something like this. Which means I'm also going to have to move the slit up. Mm. So I think both of these slits need to move up to the top of this peak. The slits that go all the way through, because now the surface is broken. It's able to pass straight through. But I think you're going to need something like that. Or you're not going to be able to get your finger in there to pull the tub out. Yeah, I think that's going to be necessary. Now, the good news is those slits should be already there. Control D. And that is the exact height I need them. Right there. Delete that now. All right. So let's separate this. You can hide this. Okay, separate. Yeah, there they are. So this one and this one, I'm going to join them together to make them easier to manipulate in the future. This needs to come up to 0. There. Now I can join these all together. And now I can join these. I did not ask you to select that one. Okay, yeah, I think that's what it's going to be needing. All right, so okay. So I need to delete the double dip. And I need to delete the lick my balls. Bye-bye. Let's delete the double dip factor. Let's just delete everything. Yep, let's delete it all. Okay, yeah, good thing I caught that, because that would have been a problem. That would not have been easy to deal with. This eliminates the bridging problem, too. Okay. Now, I think this is more complicated than this, though. I have two openings. So outside, inside, outside, inside, outside, inside, outside. No, we're good. We're good. Because it's symmetrical, we're good. The extension does not need to be modified. I can bring everything back. So this is going to be the double dip. Export ST. Oh, no, no, no. I don't want to do that. Delete. Double dip. Let's make sure it slices. I see a retraction. No, I don't. But why did I lose the inside? I broke something. I broke something. That should not be doing that. Why is it doing that? Once it connects here, it doesn't reconnect until there. I did something wrong. What did I do wrong? Let's hide you. Make you transparent. Oh, I did it height above the cut plane instead of height above the floor. Crap. I know what I did wrong. There it is. Is that the cut plane? Yes, it is. I need to be 0. It is 0. What did I do wrong? Let's hide this. Oh, crap. Yeah, I forgot about that. These legs. I figured they'd come back to bite me one day, right? Yeah, figures those legs would come back to bite me. Oh wow, yeah, that's they were irrelevant before, but now they're not irrelevant anymore. Should be able to just chop these. an arbitrary height. Bring it down to 0. Stretch it out a little bit. Bring everything back. Let's hide the extension. There, that should do it. Hey, DeWitt. No big deal. We're making sauce cup dispensers that print in vase mode. I think I fixed it. Delete. Export. STL. That should do it. There we go. Where did I get that weird line back here? Oh, that's the tip of the point here. Yeah, that's the tip of the point right there. I'm not sure why it's doing that little movement there, but that's okay. I'm probably going to want to get rid of those too. Yeah, it'll be okay. Yeah, I think that'll work. I mean, there's a couple of things I could correct, but I'm just not worried about it. Yeah, that works. Save that as double dip. Okay. Now the extension should be unchanged. So I should be able to drop the extension in there. Bring it back. Yes. So extension, export, STL. Join these together to make the super long. Come on. Export STL. Oh, I just did that. That's fine. DD long, tall. DD tall. So now I should be able to remove this, put in the DD tall, and then simply tell the slicer only print to 245 millimeters. And now I'll get the exact height that I need. Perfect. And that also eliminates that bridging problem too. This should work out pretty good. That angle should be enough depending on cooling. It's possible it might be a little sloppy. It's also possible I don't care. Yeah. Oh, did that get rid of that little weirdness I had there? Yes, it did. That got rid of that. Oh, no, it's still there. That's all right, though. Oh, wait a minute. Is that a gap? Oh, that's an actual gap. That's an actual gap. Okay, I think if I change the start point. So let's do X. What's my G code? 235. Actually, I think it's 225, isn't it? Or is it 235? I think it's 225. see here. So you want X at 0.5. And let's do it at, I don't know, 150. Excuse me. Why do you keep doing that? 112.5 by 150. Actually, just optimize for speed might be the key there. Nope, we still have a gap. No, it's not a gap. It's an overlap. I'm okay with an overlap. Overlap is good. Gap bad, overlap good. It'll bulge a little bit, and that's okay. It'll be adhered together. That's all that matters. There. That looks good. We're going to print that. Yep, I like that. And it's only going to take 95 grams of filament. What was that? What's this? Technically, we went there. Nope, that was Tuesday. There we go. That's it. All right, I like this. I'm gonna wait to upload this to Thingiverse until after I print one. So tomorrow I'll put this on Thingiverse. I want to make sure this prints okay first, and then go add the notches to the other two. Although the sauce packet one doesn't need it, but the single one of this will probably need it. Yeah, that's it. And once I verify it prints okay, I will upload the Thingiverse, and I will update the description of this video to show the link for Thingiverse, and go from there. So that's it. I will see you guys later. I want to go put this on an SD card, and I want to go print this because this looks kind of cool. You guys have a great day. If you have any questions, be sure to post a comment. Don't forget to check out my affiliate links down below. That is how I earn my income. There's PayPal, there's Amazon links. That's an Amazon associate I earn from qualifying purchases. That's it. I will see you guys all later.